Today we're talking about probability of independent and dependent events. Okay? Similar to yesterday, when you're taking the probability of something, you're taking the successful outcomes over all possible outcomes. Okay, so we need to understand the difference between independent and dependent. Okay? Independent events are where the outcome of one event does not affect the outcome of the other event. Dependent events are where once one thing happens, it'll change the outcome of the other event. Okay? Remember that probability when you have and means you're going to multiply, and when you have or, remember you're going to add. Okay? So there's notes here. If you have a dependent event, you take the probability of A times the probability of B once A has occurred. Okay, so we're going to go through and just kind of talk about the difference between independent and dependent first. So, identify whether the following are independent or dependent events. So again, using your fingers without yelling things out, independent will be 1, dependent will be 2. So on A, the color of a car selected at random and the type of transmission selected at random. Do you think those are independent or dependent? What we mean by that is that, like, if you pick a red car, does it have to have this transmission? Yeah. So what it's saying is, like, once you pick the color, does that, you're automatically set and you have to have this? Yeah. No. So those are called independent. So that would have been a 1. Okay? These are independent. Because it does not matter what color your car is, you can choose any transmission that you want. Okay? Do you get what I'm saying? Yeah. Okay. All right. A letter of the alphabet selected at random and then another letter selected at random. Okay. This is a trick question. Yeah. It could actually be independent or dependent. So I would actually accept either one. Independent or dependent. Now, so I'm going to explain to you why. What would be the difference? So an independent event would be if you chose a letter, threw that letter back in the whole bag, and chose another letter. Those are independent because whatever letter you choose first, could you choose that same letter again? Yeah. Yes, as long as you're putting it back in the bag. Okay? So if it says that it's replaced, like they put it back, then that means that it is independent. Now, how to make it dependent would be is if you chose a letter from the bag and then you set it outside. So that would be dependent because whatever letter you chose the first time, you couldn't choose that letter again. And that would make it dependent. Okay? So if you're replacing things, they're independent. If you're not replacing, then it's dependent. All right. Completing your homework and earning your grade on the test. What do you think?
No, independent. You can get an F and that's earning a grade.
No, the grade that you earn. You're right, you're still earning a grade, but do you think that homework completion is going to affect your grade versus not doing your homework?
Well, it's like your overall grade, it's a grade on the test. That's why.
Wait, no. You're like your grade on the test. Yes, everybody's going to earn a grade.
Yes.
But the grade you earn kind of depends on the homework you do. I would disagree. If you do your homework and actually do your homework and not copy your homework from people or just write down the answers, okay? If you do your homework and try to learn, you're going to get a better grade than somebody that plays on their cell phone in class, doesn't really pay attention, copies the homework.
They're all just vague. You're very vague and ambiguous questions.
Okay, so we're not arguing about this right now. We are just trying to understand the difference between independent and dependent. Normally, if you do your homework, you're going to do pretty good on the test. If you don't do your homework and you copy things and you don't pay attention in class, you're not going to do good on the test. Okay? Really? Okay, D. Okay, rolling a die and getting a 1 and then rolling the die and getting a 3. So when you're rolling a die, is it independent or dependent? Very good. Because could I have rolled the die and got another 1? Yes. Okay. So those are independent because you can get the same answer twice, right? It doesn't matter that I got a 1 on my first roll. I could still get a 1 on my next roll. Okay. So example 2. A card is selected from a deck of 52 cards. What is the probability that it is a black card or a 10 card?
30 out of 52. Oh, yeah.
Okay, how many black cards are there?
26.
How many 10 cards are there?
4.
But,
2.
how many do I have to subtract out?
2.
Do we understand why I'm subtracting out 2?
Yes.
Because if we go over here to everything that's written on the board, so I have all these black cards, which we said totals 26. So there's 13 and 13. So that's where I got the 26. Okay? And then it says a 10 card. Well, if you look here, I'm adding a 10, a 10, a 10, and a 10, which made 4. But these two 10s, I added them with the black cards, and I also added them with the 10s. So I added them 2 times. So that's why I have to subtract out those 2 black 10s that I already added. Okay? So when we do all that, that becomes what? 28 over 52, and can that reduce?
Yeah.
It does end up being 7 over 13. You can divide by 4 to the top and the bottom, and you get 7 over 13 as your answer. Questions? Okay, moving on. So a lot of this is similar to what we did yesterday, okay? But we're just talking about dependent and independent as well. Okay. A drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and then replaced. Since it's taken and then replaced, would you say that's independent or dependent? Independent. Very good. Another paper clip is taken from the drawer. What is the probability that the first paper clip is red and the second paper clip is blue? So the first thing we always need to do is what?
So second paper clip wasn't replaced?
It doesn't. You're just choosing 2. So you're choosing one, putting it back, choosing another one. Okay, we're not doing a third, so it doesn't matter. Okay, so you always need to find your total. I think somebody said that. So what is my total on here? Okay, so total equals 12. Now, did anybody see the word or in here in terms of when we were finding the probability? No, but we saw and, which means we're going to multiply. Okay, so what is the probability the first paper clip is red?
3 out of 12.
Very good, 3 out of 12. And then am I going to add or multiply? Multiply. And then, so it's replaced, so I still have a total of 12. And this time they want to choose a blue, and so what's that probability? 5 over 12. And then at this point, what do we always do? Reduce. Can anything reduce? Okay, 3 divided by 3 is 1. 3 goes into 12 4 times. Can anything else reduce? No. So anything on the top can reduce with anything on the bottom, but you can't reduce 2 bottom numbers. So will anything else reduce? No. So 1 times 5 is 5, and 4 times 12 is 48. And this will not reduce further. That's your answer. Questions? All right, example 4. A drawer contains 3 red paper clips, 4 green paper clips, and 5 blue paper clips. 1 paper clip is taken from the drawer and it is not replaced. So this time realize it's saying it's not replaced. So is this independent or dependent? Dependent. I'm just going to put an I on that first one to remind us it's independent. This is dependent. Okay. What is the probability that the first paper clip is red and the second is blue? So again, what is my total? Okay. So when I'm choosing my red, what is my probability? 3 over 12. And it's still and. We're multiplying. And then how many blues are there? 5. But I took out a red, so what is my total now? 11. So be careful because you need to make sure that you subtract on your total. Okay? We didn't have to subtract on the blue because we took out a red, right? So we still have the 5 blue, but we only have 11. Okay, can anything reduce on this one? Yes, 3 and 12. Good. 3 divided by 3 is 1. 3 goes into 12 4 times. Can anything else reduce? Gentlemen, thank you for paying attention and not talking. 1 times 5 is? And 4 times 11 is? And that is my answer. Questions? Okay, example 5. You have 10 coins. There are 3 dimes, 5 quarters, and 2 pennies. So what is my total? 10 is my total. Okay, so be careful. Don't try to add 10 in that mix. Okay, a coin is selected and replaced 3 times. Selected, replaced, selected, replaced, selected, replaced, which means it's independent or dependent? Independent. Okay, because you could choose the same coin every time. It says, find the probability all 3 coins are dimes. So what am I going to write? There's 3 dimes out of 10. I take a dime out, I replace it. Times 3 over 10. Take it out, replace it. Times 3 over 10. Very good. Can anything cross-cancel and reduce on this problem? No. So you always multiply tops with tops, bottoms with bottoms. 3 times 3 is 9, and 9 times 3 is 27. 10 times 10 is 100, and 100 times 10 is 1,000. And it would not reduce, so that is my final answer. Okay, next one. A coin is selected and not replaced. 3 times. Find the probability all 3 coins are dimes. So again, we're doing it 3 times, right? Okay, so how many dimes are there the first time we're choosing it? 3 out of 10. It is not being replaced, which again means it's what? Dependent. And so it's going to end up being how many? 2 over 9. And then 1 over 8. Okay, do we notice anything here that reduces? Okay, 3 goes into 3 one time, 3 goes into 9 3 times. What else? Okay, you can do 2 and 10 or 2 and 8. 2 divided by 2 is 1, and 2 goes into 10 5 times. Everything on the top is now 1s. What is 1 times 1 times 1? 1. What's 5 times 3? 15, and then 15 times 8 is 120. 15 times 8 is not 35. Okay, so that's my answer, 1 over 120. Okay, any questions?